So, lecture number 13, how to implement atomicity and durability in transaction. As we already know what is atomicity and what is durability. Now the question is how to implement atomicity and durability in transaction. So there are some several methods with the help of which we can achieve this task. So number one is shadow copy scheme. As the name suggests, there is something related to copy. Okay, so based on making copy of DB, assumption only one transaction is active at a time. So these are the two basic things. I will explain you shadow copy scheme in a very easy manner. But before it, you have to understand, you have to read these 3 points. A pointer called DB pointer is maintained on the disk, which at any instance point to a current copy of DB. So we want to achieve atomicity and durability. So for this, we are making a copy of DB. What we are doing? We are making a copy of DB. So suppose this is our DB, and we are making a copy of DB. Copy of DB. Okay. Now there is a pointer called P pointer. This pointer points to this DB. Copy of DB. Now let's suppose you are making any operation. Okay. So this copy, the copy of DB is now converted into a new copy. New copy. New copy. Now every operation that you are doing on this new copy. Initially our pointer, I will change it to like this. Our pointer points to the copy of DB, not new copy. Once you have done all the operations over there, now if you have committed, so at that time this connection got terminated. Now our pointer points to this new copy. Now you will see, and if everything is got clear, now DB is converted to the new copy. Okay, new DB copy. So in this way we can achieve transaction. Okay, and there is also atomicity, because all or none. If failure occur, then our pointer always points to our copy. But if failure is not occur and everything got in easier fashion, or you can say everything got right. Now in this way we can say if everything is right, then our pointer points to the new copy. Okay, and this new copy becomes our DB. So this is the functionality. You can say this is this is our shadow copy. Okay, so this is the diagram. Initially it is pointing to the old copy. Now you have DB pointer update for the new disk location. Now our DB pointer pointing to the new copy. Okay, all further updates are done on the new copy, leaving the original copy untouched. If at any point T has aborted, the system deleted new copy and the older copy is not affected. If T successful, it is committed as, and our OS makes sure all the pages of the new copy of DB written on the disk. DB system update the DB pointer to the point of the new copy of the DB. New copy is now the current copy of DB. The old copy is deleted. So this is the things. Now you can achieve atomicity, because all or none. So atomicity is very easy to understand, because we can achieve atomicity here. Now the question is, how can you say that we also achieve durability? Because when the system restart, suppose when the system restarts, it will read DB pointer and will thus see the original content of DB, and none of the effect of T will be visible. Transaction will be visible. So when you restart, our now DB is pointing to the original content of DB. Okay, so everything is right. So we can say durability can be achieved. Okay, T transaction is assumed to be successful only when DB pointer is updated. If DB pointer is not updated, then we can say our transaction is not completed. Okay, if system failed after DB pointer has been updated, before that all the pages of the new copy were written to the disk. Hence when the system restart, it will read new DB copy. So what is bad thing, or you can say drawback of this scheme? Because it is inefficient, as entire DB is copied for new transaction. So all about this is all about shadow copy. The disadvantage of shadow copy is it is inefficient, as entire DB is copied for every transaction. Now the second scheme is log based recovery scheme or method. It is very simple to understand log based. So if you are not know what is log, so there is thing that the log is sequence of record. What is log? Log is sequence of records. Suppose this is our one record, this is two record, three record, four record, so it is our log. A log. So log is sequence of record. Log of each transaction is maintained in some stable storage so that if any failure occur, then it can be recovered from there. So in a simple manner, I will explain you here. So log based. So log is nothing but sequence of record. So that is to start. Let's suppose A send 50 rupees to B, and A initially has 1,000 rupees. So now A has become 950. A remains 950, and the amount of A becomes 950, and the amount of B remains will add to be 250, 2050 rupees. Okay, so 50 rupees deducted from A's amount and added to the B's amount. Okay, now committed. So once committed, what will happen? This log is is been transferred to our DB, and the updation will be occurred on DB. So this is the thing. And if anything before commit occurred, then log is totally deleted and nothing will change in the DB. So this is it, log based. So you can learn something more about it and explore with these 3 points. If any operation is performed on the DB, then it will record it in the log, but the process of storing the log should be done before the actual transaction is applied on the DB. Now stable storage, deferred DB modification. Now the third scheme is our deferred DB modification. Okay, deferred DB modification. If the system crashes before T complete, or if T is aborted, the information in the log are ignored. If failure occurred while this is updating is task plan, we perform redo. So deferred DB modification is nothing but uh, just a modification of our log based recovery method. Okay, what we have done here, deferred the execution execute late. So execution will be slightly late, you can say, ensuring atomicity by recording all the DB modification in the log but deferring the execution of all the writes operation until the final action of the T has been executed. Log information is used to execute deferred writes and when T is completed. If system crashes before T completes, or if T is aborted, the information is log are ignored. If failure occur while this updating is task place, then we perform redo. So now the fourth type is immediate DB modification. Now immediate DB modification is just an modification of our log based method. So here you will see that is initially A has 1,000 rupees and B has 2,000 rupees. Let's suppose A sent 50 rupees to B. Now amount of A become 950 and amount of B become 200, 2,500. 50 rupees, 2,050 rupees. Okay, and then keep coming. So just a new field, you can say, new field is added. So this is our immediate DB modification. Now what are the uses of this field? Now you can say the time the time that taken the time taken by the time that takes take by our log based recovery is high, but immediate DB modification takes low time, as updation to the DB after committing is become very easy because everything is in the log system. Okay, so it is very easy to update. So this is the importance of immediate DB modification. You can learn more about it just by reading these 3 points. In the event of crash of T failure, system use old value field of the log record to restore the modification. So this is it. I hope you understand this point. Thank you.